that should be enough time to read 2 paragraphs. What those 2 paragraphs are essentially saying is this: money earns money. If you have money and you do not act like a crazy person and stuff it into your mattress, your money will earn more money. You and I do not have a lot of power to make our money earn more money. I cannot take my measly salary and go to a multi-million-dollar company and say, hey man, I got like $100 a month I can chip in and you guys can go and do some good work with it. Why? Because $100 doesn't mean anything to that multi-million-dollar company. Does everybody understand that? However, if all the people in Canada put $100 a month into a bank, then that bank has access to, assume we're only talking about adults, so that would be 20 million Canadians. At $100 a month, that's that's $2 billion a year that the banks control. Now, can the banks go to multi-million-dollar companies and say, hey, we got billions of dollars to help you? Yes. Now, since the bank is the one offering up that money, the bank gets paid by those companies. Everybody with me? But it's not the bank's money, is it? It is your money. It is my money. It is the neighbor down the street's money. It is old widow Charleston's money. Because they are using our money to make more money, they pay us. They do not pay us as much as the bank makes because we only chipped in a little bit. Does everybody understand? Okay? Every bank in Canada, the major 5 banks, all earned profits of $1 billion each last year. At least. $1 billion is a colossal amount of money. It is more money than you can actually comprehend. We've done this gag in the past. You people are all 1 million seconds old. You turned 1 million seconds old when you were 11 days old. None of you are 1 billion seconds old yet. That's how much bigger 1 billion is than 1 million. There is one person in this room that is 1 billion seconds old. Me. And I turned 1 billion seconds old when I turned 37. That is the difference between 1 million and 1 billion. So as you get older in life and you hear governments talk about, oh, it's only $1 billion, let's remember this. Or you can remember Justin Timberlake in The Social Network where he says, $1 million isn't cool. $1 billion is cool. Okay? That is how money works. It is very simple. People act like it's complicated, but it's not. Get some money, put it in a bank, get more money. There's a commercial on TV right now for a bank that says you start with a little bit of money and then you put that money in the bank and then you get a little bit more money and then you put that money in the bank and then that gets a little bit more money and you put that money in the bank and you get more and more and more and more and more and eventually you're a rich person. Everybody understand? It's that simple. The first type of interest is even called simple interest. You can read about simple interest right here in the second paragraph. Simple interest is applied to very small, short-term investments, such as your bank account. Because your money is going in and out of that all the time, they don't really apply long-term interest to it. Everybody cool? All right. We're going to start with that because it is indeed simple. So, in this white space right here, I am going to write the formula for simple interest. It is a formula, so it always works. Interest equals P, R, T. What math is happening between P and R and T? Multiplication. Now, do those letters mean anything to most of you? Maybe they mean stuff to some of you. Maybe they don't mean stuff to some of you. But you all know that every letter in an equation has a value, yes? This equation has 4 values. I equals an amount of interest. It's an amount. It's money. When you do this formula, you will find out how much more money you are getting back. Okay? P stands for principal. Principal is the amount you started. R equals rate. That's the interest rate. Interest rates are given as a percent. Do we use a percent when we are doing calculations with percent? If I told you that the skis you are buying for Christmas are 25% off, do I use 25? No, what do I use when I'm actually doing the math?
0 point something like that.
0.25, yes? So the percentage, the rates are given in percent, but we use the decimal. Point XY. Never more than, well, it might be more than 2. Everybody understand? And then the last letter is T. And this is another thing that is a little complicated. T is time, but we only measure it in years. Only. So let's apply this situation here. There's some new words in here that you may not be aware of. That word, annum. Annum is from the Latin word for year. Annum means per year. You may want to write that down. So, once again, your bank, where you guys have your bank account, if you have a bank account, is using every cent of money that you have in the bank. Your money isn't actually there. Does everybody understand that? The bank, CIBC, Scotiabank, TD, whatever, is not like your piggy bank at your house when you were 5. Your money is not there. Money is there, but it is not yours. If you need money back from the bank machine to go and buy yourself a Slurpee, that money, the bank gives it to you from their pool of money. If you buy a house, your bank does not give you $500,000. Your bank allows you to use $500,000. It gives money to the other person whom you bought the house from. But it is not your money. Does everybody understand? Because the bank is using your money to help other people, they pay you for that privilege. That is interest. All right? So, assume your bank pays you 2% per year for holding your money. You leave $500 in the bank for 1 year. How much interest will you earn? All we do is we do the formula. I equals PRT. I is what we don't know. What is our principal? 500. Now, if you write this out, it is impossible to do it wrong. What's our rate? 2%. But we don't use 2%. What do we use? 0.02, not 0.2. Percents are over 100. Yeah. And what is your time? 1 year. So, if you write it out, it is impossible to do it wrong. I equals 500 principal times rate, 0.02, times time 1. How much interest will you earn? Grab your calculator, figure it out. It's pretty easy. And it is $10. Not much, but $10 more than you had. Now, if you leave that in the bank for 10 years, you've got an extra $100. Everybody understand? Easy peasy lemon squeezy. Now, let's look at the second one. What has changed? It is in days. So, did my principal change? No, I still have $500. Did my rate change? No, I still have 0.02. Did my time change? Yes, it is no longer 1 year. It is a fraction of a year, yes? What fraction? 45 divided by 365. Now, don't give me any horse crap about it being a leap year or not. You just do 365. Okay? So, how will it change my calculation? My interest will it still equal 500? Will that 500 still multiply by 0.02? But now, instead of multiplying by 1, what does it multiply by? 45 divided by 365. The formula is easy. It's slightly more difficult to put into your calculator. Everybody try. And what is it? $1.23. If you did not get $1.23, then you need to re-examine how you entered this into your calculator. If you did get $1.23, then you know what you're doing, and I don't want to mess with how you did it. Do you understand? Did everybody get $1.23? Everybody? Good. Now I don't have to worry. So now, let's do some actual real-life stuff here. 6 months before Christmas, Heather invested some money to buy gifts for her family. She will earn $33 on her investment. How much did she invest? So since it is simple interest, what formula are we using? I equals PRT. And again, if you write it out, you cannot do it wrong. Do I know how much interest? What?
No.
Yes, you do. Read the question. 33. Do you know the principal? How much she started with? No. So that is P. Do you know the rate? 0.055. Remember, rate is always the percent value divided by 100. And do we know the time? 1/2. Or why is it 1/2? 6 months out of 12. Because time is always in years. So now, if I write it out, I can't do it wrong. 33 is my I equals P times 0.055 times 1/2. How do I solve this? I would do this first, so I only have one coefficient. 33 equals 0.055 times 1/2. So I go to my calculator, and I get 0.0275 times P. Now what math do I do? I divide both sides by 0.0275, and P equals what?
1,200.
1,200. Can everybody work this very simple formula? And all you do with all of them, fill in what you know, do your division. Because there's no adding or subtracting. It's all dividing. Everybody good? All right. Now, let's talk about a more realistic approach. Read that sentence. What are the important words in that sentence? When do you get your interest? End of the month. What's weird about that interest? Pardon? It's for the minimum amount of money in your account. Why is it the minimum amount of money in your account? Partly. What is the bank doing with your money? Spending it. Right? The minimum amount of money in your account is the maximum amount of money the bank has available to it, correct? Does everybody understand that? If I have $10,000 in my account in the middle of the month, the bank has access to that $10,000, doesn't it? But if on the 16th of the month I take out $9,000, now what does the bank have access to? Only $1,000. So they're only going to pay me interest on the amount of money I left in there for them to use. Does everybody understand? That is what minimum monthly balance means, right? So, let's check this situation out. April 1st, beginning or end of a month? Beginning. So now, as of April 1st, we are starting a new cycle. We are going to pay interest on the minimum amount in Aaron's account. All right? So, read that first sentence. What do I know? How much money was in Aaron's account on April 1st before she did a deposit? Before she did a deposit. She starts with 250.31. Yes? Then what does she do? Deposits. Does that make the money in her account go up or down? Up. So she is going to add 850.25 to get her to a total of what? You will add that up. Is everybody good? So right now, if she doesn't touch her account, she is going to get interest on that much money. Agreed? Everyone understand? All right. But, like all people, she needs to use her account throughout the month. What is the next thing she does? So she did an April 1st deposit. What did she do on April 15th or April 10th? April 10th, she withdrew, WD. Is that going to make her account go up or down? Down. So it is a subtraction of $375, correct? So what's in her account now? 56. 9, 10, 5, 2, and 725.56. Everyone agree? So, if the month ended on April 10th, where is her interest going to be calculated from? Well, 725, because that's the minimum that's in her account, right? What happened next? She deposits another $850. On April 15th, she does a deposit. So she adds $850.25. 1, 7, 5, 7, 15, 75, 71. But she also does what? Withdraws $400. Leaving her with $1,075.71. Everybody agree? Everyone agree? Okay. So that is what is sitting in her account on April 15th. Did she do anything else with this account? No. So April 30th rolls around and the bank says, okay, Aaron, it's time for us to do your interest. Is a savings account a short-term or a long-term investment? Short-term, because money's going in and out of it, right? So it's going to be simple interest. I equals PRT. I'm trying to find the interest, so that's not got an answer. My principal is what? No.
0.02.
No.
Oh, your principal.
What is it, Burke? 725.56. Because that is the minimum amount of money that was in her bank account that month. Does everybody understand? Is everybody good? What is the rate? So 3% is what we say. What is the number that we actually use? 0.03. And what is the time? 1/12. Why is it 1/12, Louis? Because we always do time in years, and this is only 1 month. Is everybody cool? So, all we do is plug in the equation. 725.56 times 0.03 times 1/12. I don't want to tell you how to punch that in unless you're getting the wrong answer. What is it? $1.81. Did everybody get $1.81? All right. Now again, it doesn't seem like much. But the more money you have in your account, the more money you're going to get back from the bank. And let's be honest, it's free money, right? Would you walk by a toonie sitting on the ground? Of course not. You'd pick it up, right? So why do Canadians not save money? And I shouldn't say Canadians. Why does the entirety of the world not save money when banks are willing to give you free money? Why are we not saving? Damn right. The vast majority of Canadians and Americans and British people and Australians and Mexicans and Ecuadorians and Brazilians and Portuguese and Spaniards and so on and so on and so on do not have enough money to live the rest of their life unless they work until they die. Canadians, especially, for every $1 that I earn, on average, I owe $1.33. Does everybody understand what that means? If you pay me $1 for my job, I have to pay other people $1.33. I am losing 33 cents for every dollar I earn. So if I earn $1,000, I am losing $330 in actuality. Why? Because I need an ATV, a snowmobile, 2 cars, a boat, an Xbox One, a PlayStation 4, a Nintendo Switch, cell phones for the whole family. And I also would like to retire when I'm 65 so I don't have to work until I actually die. And yet, no matter how many times we do these classes, no matter how many times I show you how easy it is to have your money make you more money, most of you are not going to save. I can't fix that. All I can do is tell you, start. The earlier you start, the better. The more you get used to losing a little bit of your whatever income you have right now to saving, the more you will get used to doing it when you are older. I did not start until I was way too late in life. Start now. As you will see from this unit, how much difference it makes if you start when you're 15 instead of when you're 35. Now, that is simple interest. Everybody cool with that? I equals PRT. I don't think I need to go over it anymore, do I? Okay. You can read that paragraph. We'll talk about it in a minute. Go. Has everybody done reading? Does everybody understand? In simple interest, nobody cares about the interest. You get it at the end of the interest period. It goes into your pocket. Then they start again with your original principal. Everybody cool? In compound interest, you don't get that interest. They put it back into the bank. So if you started with $500, like the question we just did, and you earned $1.81 at the end of that month, right? Or whatever it was, I can't remember now. So this $1.81 would go back into her account right here. And she would then have $1.81. If she didn't touch her account, this 2, 5, 7, 7. This becomes her new principal. And then this would be RT'd. Does everybody understand? In compound interest, your found money makes you more money. Everybody with me? So your free money that they just gave you, they're going to use that free money and then give you more free money. Everybody get it? What is the key word in that sentence? Free money. You don't have to do a thing. You do not have to work for it. It just shows up. I will give you an example of this. When my wife worked at Chehalis School, just over by Hemlock Mountain, she put approximately let's see, she made 2,500. She put about $20,000 into an account. Okay? Every check, they took a little bit of money off her check. She hasn't worked there in 10 years. Every year they send us how much that investment is worth now. Okay? So over the course of 10 years, she put in $20,000. If she had put that in her mattress, how much would she have right now? $20,000. She actually has well over $100,000. And she has not worked at that job for 8 years. Does everybody understand? She has 80,000 free dollars. That's it. All she did was put money in a piggy bank. But not a piggy bank, a bank. Everybody with me? A lot, because we put it in risky investments because we didn't care. Because it's free money. I don't know. Everybody cool? So, let's do this thing. We are going to start with $1,000. I'm going to show you the difference between simple and compound. I start with 1,000. Everyone agree? What's my interest rate? 0.08. So, I equals PRT. It's 1 year, year 1, so T is going to be 1. What's principal times rate? $80, agreed? So I have $80 of interest, so how much money do I have now? How much? $1,080. I get an $80 check from the bank, I put it in my pocket, I walk out the door. Everybody with me? So, what's my principal here now? No. 1,000, because it's simple interest. I got this $80, Lucas. They gave it to me, and I went and spent it. Okay? My 1,000 is still there. So what's this going to be? $80. Everybody with me? Okay, now, if I didn't go spend it, what would this be? It would be 1,160, yes? But because the bank is only paying me on my original principal, what goes here? 1,000. What goes here? 80. What goes here? 1,240. What goes here? 1,000. What goes here? What goes here? 1,320. 1,000. 80. 1,400. Agreed? What is the interest I earned? 80 times 5, I earned $400. Does everybody see how it works? Everybody cool? All right. Now, in compound interest, what's going to happen with this 80 each time? It's going to be added.
You don't still keep staples for that copier, do you?
Yeah, there should be some there. They're in a weird, like, rifle cartridge.
Yeah, I know you.
Okay.
This one, Nick.
Yeah. What's the principal? Still 1,000. What's my rate? Still 0.08. What's my interest here? 80. What's my new principal? 1,080. Now, if it's a compound investment, what does this become? 1,080. Does this stay the same? The 0.08 does. But what is going here now? 1,080 times 0.08. I'm going to write it out to show you. It's going to be P times 0.08, which is how much money? 86.40. So what does this become? 1,166.40. Everybody cool? So already I've earned $6 more. Now what goes here? 1,166.40. What goes here? Use your calculator. Tell me what the answer is. What? 93.31. What goes here? $1,259.71. What goes here? What goes here? $100.77. I have 8. Check your next digit. 8. What goes here? $60.49. I get 106.84 and 1,469.33. My total interest earned, 469.33. Does everybody see? Over 5 measly years with a very small investment, it's a $70 difference. I can't read my own writing. Is everybody good? Now, you're intelligent young people. There's a formula for simple, yes? I equals PRT, correct? So there's obviously a formula for over here, right? What did I start with? A principal, yes? That's going to be the same in both cases, agreed? Now that principal, at some point, multiplied by my rate, yes? So it's going to multiply by my rate. Everybody cool? Now, this is where the difference occurs. In simple, the principal never changes, does it? It's always the same, yes? But in compound, that principal, it is always the same, but then I add to it every time, don't I? So I have to write 1 principal times 1 plus my rate. Everybody cool? And then I got to do the time, yes? What's the time? Got to multiply by the time, right? So at some point, I got to have time over here, correct? There's going to be a multiply by time. Is everybody good? Now, what do I know about this time? It's going to be in years. And how many times am I getting interest here? When do I get it? Every what? Every year, right? So since it's time in years, my rate is going to be over the course of the whole year, yes? And then I'm going to multiply by my time in years. Is everybody good? Everybody cool? That's the basic understanding of compound interest.
So in that time, you just need to multiply by 5.
So what would go here? It's not principal times just rate. What am I really multiplying by? 1 plus my rate. What was it? What's 1 plus, what was my rate? 0.08. So what's going here? 1.08. Correct? Everyone agree? Now, if it was 1 year, I'm multiplying this number by itself once, correct? What if it was 2 years?
2.
I'm multiplying this number twice by itself, correct? Well, what math is that when you multiply something by itself? Squared. What if I did it 3 times? What would it be? Cubed. What if I did it 4 times? What would it be? To the 4th. Everybody with me? Because this principle is repeating, it is not just times t. What is it? It's an exponent. Is everybody cool? All right. Let's turn the page over and let's learn some more stuff. Compound interest is sometimes paid more than once in a year. Sometimes, if it's paid annually, how many times do you get it in a year? Once. Right? Every year you get it. Once. Semi-annually, how many times do you get in your interest? Twice. So you get 2 interest payments a year. What if it's quarterly? 4 interest payments a year. What if it's monthly? 12. What if it's weekly? 52. What if it's daily? 365. Now, this changes our formula, doesn't it? We know our formula is a principal. We know it's 1 plus a rate, right? Everyone agree? Now, here is where it's going to change. If you are getting your interest twice a year, then that rate is being divided by 2, isn't it? So I have to divide by n. N equals the number of payments per year. So in this case, it's 1. What's n here? 2. Everyone agree? Now, I know that the t is always in what? Years, right? We know it's an exponent, and we know it's always in years, right? But if I'm being paid twice a year, then how many payments do I get in that 1 year? 2. So I must multiply this by n. Does everyone understand? That is the formula. Now notice it is different. It doesn't give me the interest. It gives me an amount. So I have to find the interest by doing subtraction later. Everybody cool? So let's run this through with our same $1,000. If I do this for 1 year, we already know what the answer is going to be, yes? If I do this for, 5 years. Because that's what we did on our chart, right? How much did we end up with after 5 years when we only compounded once a year? We just did the whole chart. What was it? 1,469.33. Yeah? Okay, now watch. You don't have to do a whole chart. What did we start with? 1,000. 1 plus, what was our rate? 0.08. And how many times a year am I getting money? Once. So that would be divided by 1. So it's just 0.08, right? And how many years did we do this for? How many years? 5 years. And I got paid once a year, right? So it's 5 to the 1. Now, watch. Without a chart. 1,000 bracket 1 plus 0.08 divided by 1, close brackets, to the exponent, open brackets, 5 times 1, close brackets, equals 1469.33. Is everybody with me? Everybody cool? All right. So, how is this formula going to change here? Is the 1,000 the same? Yep. 1 plus, is the 0.08 the same? 0.08. But now, how many times a year am I getting that money? Twice. So if I'm getting it twice a year, I get those 5 years, but it's happening twice. So what is my exponent now? 10. Now I can do that in my head, so I don't need, when I punch this into my calculator, I don't need those brackets, do I? The second set of brackets. Do I need this, the 5 times 2 up there, or can I do that in my head? I can do that in my head. But when we get down to the bottom of this, and it's being compounded daily, can you do 5 times 365 in your head? No. So that's why I showed you with the brackets. Everybody cool? Fill this in now. Go. When you're done, you can check against mine and make sure you're using your calculator correctly. Stop after quarterly and then check your answers against mine to make sure you're using your calculator right. Everybody cool? I've done up to quarterly. Has everybody else? You want to see if you're using your calculator right? You want to make sure you have the same red and green numbers that I do. There and there. Is everyone good? Okay, continue. Now, all of you should notice that we make more money depending on the compounding, right? But you all also need to notice something. Where was the biggest jump? Where did I make the most extra money? This is what I started with. Where is the biggest jump? Semi-annually. So, if you can find an investment that will pay you semi-annually, that is your best bang for your buck, right? Because now you go all the way down to you're only making $11 more. So you got to think long term, yes? If you're going to put something in a bank account and not touch it for 80 years, then you want this one, don't you? But if you're going to need it in 5 years, maybe you only want this one. Everybody understand? You've got to do the work, or you got to pay somebody to do the work for you. Now, my argument is, why would you pay somebody to do the work for you? That's the formula. Can you use it? So do you need to pay somebody to do that calculation? No. Because there are investments you can do that are guaranteed. The bank says, you leave your money with us for 10 years, we'll pay you 4.25% per year. You know what's coming out of that in 10 years. Right? You don't need to pay somebody to do that. You can figure it out. Now, if you're going to be moving your money all over the place and trying to live your life, maybe you want to be paying somebody to help you out. Everybody with me? All right, so your job now, today, is to do page... I want you to stop at 12. Because all that is easy peasy. It's just using the equations. So you stop at number 12, and that's your homework. When am I going to show you the right answers and expect to see it done? Thursday. Because what are we doing tomorrow? Test on trig. Everybody good? Any questions? It's only 2 formulas, right? Go. Yes. What? Yeah, of course.